Alright, now we continue with example 2 from previous semester papers, October 2016, question 2A, 5 marks, right? Under linear approximation using differentials, alright? Use differentials to estimate the value of 15.99 the power of 3 over 4 plus 15.99 the power of half and give your answer correct to 3 decimal places, alright? Alright, first, we list all 4 steps to solve linear approximation. Alright, this is 4 steps to solve linear approximation. Alright, from the final step, okay, the formula is fx naught plus delta x approximate to fx naught plus f prime x naught times delta x. Right? Okay, x means the given decimal numbers, x naught means the nearest whole numbers, and delta x means the small change, which is decimal value between -1 to 1. Right? So from this formula, okay, we need to write the given decimal numbers first, okay, to find x naught and delta x. Okay, so this is the given decimal numbers, which is 15.99. Alright, so from here, from the given decimal numbers, which is x, okay, we need to split to x naught plus delta x. Okay, x naught means the nearest whole numbers, right? So the nearest whole numbers of 15.99 is 16, alright, not 15, okay? Alright, so our x naught is 16 because 16 is the nearest whole numbers of 15.99. Then we split to, okay, 16 plus something to get back 15.99. Alright, so means that we need to plus negative 0.01. Okay, because when 16 plus negative 0.01, we will get back 15.99, which is the given decimal numbers here. Right? So from here, okay, we can identify the value of x, the value of x naught, and the value of delta x. Alright? So, first step, we need to identify x, x naught, and delta x, right, from here. Okay, because from the formula, we need to find x naught, okay, and then we need to find delta x, and then we need to find fx naught from step 2, and we need to find f prime x naught from step 3 before we can use formula number 4 here. Alright? Okay, now when we compare our x equals to 15.99, okay, x naught equals to 16 and delta x equals to negative 0.01. Right? Okay, and after that, step 2, we need to find fx, okay, and the value of fx naught. Right? So how to find fx? Okay, from the given question, okay, we have 15.99 the power of 3 over 4 plus 15.99 the power of half. So we assume equals to fx. But if left hand side is fx, we need to write right hand side into the form of variable x. Alright, how to write left hand side, right hand side in terms of variable x? Okay, it's so simple. We just replace 15.99 from the given question. We replace by x. Okay, because 15.99 equals to x. Alright, so after we replace x here, so we will get fx equals to x the power of 3 over 4 plus x the power of half. Alright. Okay, and then after we find fx, we need to find the value of fx naught. Okay, so we just substitute x naught into x here. Okay, and from step 1, our x naught equals to 16. Okay, so we replace 16 here. So we have 16, the power of 3 over 4, plus 16, the power of half. Right? And after that, if we solve without using calculator, we can write 16 equals to 2 the power of 4. Okay, because we have bracket the power of 3 over 4 here. Okay, so that we can simplify 4 here and 4 in denominator of the power. Alright, and then the other 16, we can write 4 squared because outside bracket we have the power of 1 over 2 here. Okay, and after that, we can simplify 4 the power to the power of 4 here. Okay, the power of 4 here and over 4 from the power. And we simplify the power of 2 here and over 2 from the power. Alright. Because from properties of indices, when we have power and then exponent, so we can multiply. Okay. So when we multiply 4 times 3 over 4, we can simplify 4 here. Okay. And when we multiply 2 and half, we can simplify 2 here. Alright. Okay. So after we simplify, so we have 2 cubed, which is 8. And 4 the power of 1, which is 4. So we have 12. Alright? Okay. 12 here is the whole numbers. Alright? So if we have f x naught equals to whole numbers, okay, means we choose the correct 16, the correct x naught or the best x naught. Right? Alright, after that, we continue with step 3. Okay, find f prime x and the value of f prime x naught. Right? So to find f prime x, we need to differentiate from fx. Okay, in step 2, we have fx equals to x the power of 3 over 4 plus x the power of half. Alright, so from here, okay, in between is plus, so means that we can differentiate one by one. Okay, when we differentiate fx, the symbol should be f prime x. Okay, and we differentiate x the power of 3 over 4 using power rule. Alright, when we use power rule, we need to move power to the front. So we have 3 over 4 here, and then x, and then we minus 1 from the original power. So means that 3 over 4 minus 1. Okay, or minus 4 over 4. So we have negative 1 over 4 here. Right? And then plus, and we differentiate x the power of half. We move half to the front, and then x the power of half minus 1, which is negative half. Right? So this is our f prime x. And after that, we need to find the value of f prime x naught. Right? So to find f prime x naught, we just replace x here, okay, by the value of x naught. Okay, from step 1, our x naught equals to 16. So now we just replace 16 into variable x here. So we have 3 the power of 4, 16 the power of 3 over 4, and then 16 the power of negative 1 over 4 plus half times 16 the power of negative half. And if we solve without using calculator, we can write 16 here, okay, into the form of 2 the power of 4, so that we can simplify with exponent negative 1 over 4 here. Okay, and the other 16 we can write 4 squared because we want to simplify with the power of negative half here. Alright. Okay, so after that we can simplify 4 from the power of 4 and 4 from the denominator of the power. Okay, and we can simplify 2 from 4 squared and 2 from the denominator of the power, right? And after we simplify, we have 3 over 4 to the power of negative 1 plus half for the power of negative 1. Alright? Alright, then we can write f prime x naught equals to, okay, 3 the power of 4 and then 2 the power of negative 1 from properties of indices equals to half or 1 over 2. And then plus 1 over 2 and then 4 the power of negative 1 from properties of indices equals to 1 over 4. Okay. And then after we simplify, we have half. Okay. Or you want to show step by step, we have 3 over 8. Okay. 3 over 8 plus 1 over 8. Right? If we show step by step. Okay. And then equals to 3 plus 1 equals to 4 over 8 here, which is half. Or we can jump from here to half here. Alright? Okay, and then the final step, estimate or approximate using formula f x naught plus delta x approximate to f x naught plus f prime x naught times delta x. Alright? So this is the given question. Alright? So approximate to, before that, the given question actually is f x naught plus delta x. Yeah, the given question here actually means the left hand side formula, which is f x naught plus delta x. Okay. Okay, because if we substitute, okay, from step 2, we have fx equals to x the power of 3 over 4 plus x the power of half. Alright? And then when we replace x equals to x naught plus delta x, alright, we have f16 plus negative 0.01, which is f15.99. And then if fx equals to x the power of 3 over 4 plus 3 the power of half, so to find f15.99 equals to 15.99 the power of 3 over 4 plus 15.99 the power of half, which is the given question. Yeah, that's why we can write left hand side from the formula equals to the given question. Right? Because fx naught plus delta x here means the given question. Alright? So the given question will approximate to the right hand side formula, which is fx naught plus f prime x naught times delta x. Right? So fx naught, okay, we get from step 2. Okay, f prime x naught we get from step 3. And delta x we get from step 1. Right? So we replace fx naught equals to 12 and then plus f prime x naught equals to half and delta x equals to negative 0.01. Alright? So after we simplify, we have 11.995. Okay? Correct to 3 decimal places. Alright? Alright, if we check the answer using Maple, okay, we have 15.99 the power of 3 over 4 plus 15.99 the power of half. Right? The answer is 11.99499 something. Alright? So which is equivalent to 11.995 correct to 3 decimal places. If we choose the best value for x naught, okay, means that we will get the best answer, okay, the accurate answer, right? Coming up next, more examples for linear approximation using differentials. You can subscribe, like, and share to support this channel. Thank you for watching. Stay tuned. Bye. Assalamualaikum.